This is the second part of a video that talks about how we can evaluate the limits of trigonometric expressions using this limit that we have over here. So in our first video, we looked at a relatively simpler example of how to evaluate limits that have trigonometric functions in it. And one thing that I want to emphasize on about this limit over here, the limit as x tends towards 0 sine x over x being equal to 1, is that this big X over here can represent in itself another expression, another function. And we need to remember that this big X over here has to tend towards 0 in order to use this limit and in order to simplify our trigonometric expressions. So we have this example over here, and note that even though it might be slightly harder than the other example, we always use the same methodology, which is trying to manipulate our expression in order to obtain something of the form sine x over x, or alternatively x over sine x, which is also equal to, which also tends towards 1 when x tends towards 0. Now, in our previous video, we looked at two methods. The first one was by directly trying to get this expression over here by multiplying on top and on the bottom by our input over here. And our second method consisted of using a change of variable method, so to speak, in order to simplify our expression and obtain something of the form of sine x over x. So first I'll start with the change of variable. Now notice that we can factorize here the 2 in the input of tangent to get sine of x minus 2 divided by tangent of 2 times x minus 2. And now we can set y is equal to x minus 2, which simplifies our expression to the limit of y tending toward what? Well, as x tends towards 2, y will tend towards 0, which is exactly what we need. We need a variable that tends towards 0 in order to use this limit over here. So we have y tending towards 0 of the limit of sine of y divided by the tangent of 2y. Now notice that we have different inputs in the trigonometric functions. For sine we have y, and for tangent we have 2y. And so we can't use the fact that tangent of x is equal to sine of x divided by cosine of x in order to simplify our problem. In other words, we can't cancel out the sine of y with the sine of 2y that is within the tangent, because the trigonometric functions have different inputs. And notice here that we still have the case where as y tends towards 0, sine of y also tends towards 0, and the same thing for tangent of 2y. So we still have the case of 0 divided by 0. And so we need to manipulate our expression once again. So this is important. Since we have two different trigonometric functions here, we need to use this limit sine of x divided by x twice, once for each function, basically. We need to use this limit twice because we're trying here to cancel out so to speak, cancel out the trigonometric expressions so that we have an easier limit to evaluate, because this we can't evaluate as it is now. So we need to use this limit for sine of y and this limit for tangent of 2y. And the way we do that, first we will start with sine of y, and therefore I will multiply on the bottom and on the top by y. So we have the limit as y tends towards 0 of sine of y divided by y. But since I've divided by y, I need to multiply by y as well. And of course, we can't forget about the tangent that was initially on the bottom. So we have y divided by 10 of y, 10 of 2y, excuse me. And now, since we have tangent of 2y, what we need to do is multiply on the top and on the bottom by 2y in order to use this limit. But first, let's get rid of this over here, this expression, sine of y divided by y. So as you can see, we have something of this form, because here y tends towards 0, which is exactly what we want. And we have sine of y divided by y. And so, of course, this expression tends towards 1 as y tends towards 0. So this significantly simplifies our problem here, because now we have the limit as y tends towards 0 of y divided by tangent of 2y. Now, what I am about to say is really important, so make sure to understand. The tangent of x is equal to sine of x divided by cosine of x. But we know that as x tends towards 0, cosine of x tends towards 1. And so we don't have a problem with this limit, because it's not 0. We don't have a 0 on the denominator. The problem with sine of x is that it tends towards 0 as x tends towards 0. And so this might cause problems if it's in the denominator. In essence, what we need to do is get rid of the sine of x that is within the tangent in our expression. And we don't need to focus on the cosine of x, because the cosine of x tends towards 1 in our case over here. And so essentially what we need to do is have a 2y on the top, so that we can use the limit of x divided by sine of x, which is exactly what I'm going to do here. So I'm going to multiply by 2 and divide by 2. And therefore we get 2y divided by tangent of 2y. And this, let me write it down, corresponds to this expression over here, y. Well, all I did here was essentially substitute tangent of 2y with sine of 2y and cosine of 2y. Remember that here we're dividing by tangent of 2y, and therefore, since tangent is inversely related to cosine, well, we multiply by cosine of 2y here, since we're dividing by tangent of 2y. And this is great because now we have 2y divided by sine of 2y. And here, the input 2y tends towards 0. And same thing for the 2y on the top. And therefore, we can use this limit over here. Well, the reciprocal of this limit, x divided by sine of x. And so, this means that this expression tends towards 1. Hence, we get the limit as y tends towards 0 of cosine of 2y divided by 2. Now, remember, the cosine of 2y as y tends towards 0 is 1. And therefore, we get that this limit is 1 over 2. And so, I want to write down the limits that we have seen over here. So, first of all, the limit as x tends towards 0 of tangent of x divided by x is 1. And similarly, the limit as x tends towards 0 of cosine of x And so, to quickly summarize what we have done in this example, in essence, we have used our sine of x over x limit to get rid of this sign which bothers us. And we have used the tangent of x over x limit to get rid of the tangent in order to get a result for this complicated limit.